one do you want?
Got left off.
It's in the front. I kind of just
I didn't look through it yet, but she was.
Okay, so I can put mine here though, right? Okay. Far away from you.
Good evening, everyone. Good evening. Welcome. So great to see a full house tonight. My name is Robin Garrell. I'm the Vice Provost and Dean for our graduate education here at UCLA. And this is going to be an exciting evening. We're first like to begin by recognizing that as a land-grant institution, UCLA acknowledges the Gabrielino Tongva peoples as the traditional land caretakers of the Tovagar, Los Angeles Basin, and Southern Channel Islands. So we're very excited to have you here for the final round of the 2020 Grad Slam competition. We are going to select the winner who will go on to compete for the UC-wide Grad Slam Championship, winning the Slammy and even more monetary prizes. That competition will take place on May 8th. So Grad Slam is designed to showcase our amazing graduate students and their research. It's giving you a chance to learn about what they're doing, why they're doing it, what excites them about it, and to help you get a feeling for what it's like to be a scholar at UCLA today. So we appreciate you coming out tonight to learn about them and to support them. Now, to prepare, our competitors participated in Grad Slam workshops that help them focus their topics, advance their presentation skills, craft their presentations, and design their visuals. They also engaged in small group workshops to practice and help each other. And they were able to build their skills by working with professional trainers as well as previous Grad Slam participants or alums. So flash forward to February when the competition began. We held 4 preliminary rounds and 2 semifinal rounds. Altogether, 43 students competed this year, representing more than 24 areas of study. Nearly 3/4 of our students who competed this year are doctoral students pursuing degrees in a variety of fields. About 1/6 of them are master's degree students, and just under 10% are medical and law school scholars. So may I ask this year's finalists, as well as all the students here who participated in our preliminary and semifinal rounds, to please stand so that we can applaud your willingness to share your story. Yay. Yay. Thank you so much. It takes a soupçon of courage to do this. By the way, we are recording tonight's presentation, so be sure to silence your phones or pagers or those other things. The presentation will be then available. It's being live streamed, I think, to those who aren't able to join us here tonight. Okay. So you can find a list of everyone who competed this year in the acknowledgments page, which you may have picked up when you came in at the door. Okay. So tonight we're going to hear from the 10 finalists. Their mission is to articulate their research to us in ways that are understandable, compelling, and engaging in 3 minutes or less. Our panel of judges, whom I'll introduce in a moment, will score each presentation based on 7 criteria: clarity, organization, delivery, visuals, appropriateness, intellectual significance, and engagement. The judges will award up to 5 points for each category for a total of 35 possible points. This year, we're excited to announce the prizes for each of our top 4 finalists, made possible thanks to the generosity of our donors. The 3rd place winner will receive a $2,000 stipend fellowship. Our 2nd place winner will receive $3,000. And the 1st place winner will receive a $5,000 stipend or fellowship. But there's more. I think when you came in, you picked up a little card. Based on your votes, the audience choice winner will also receive $1,000. Okay. All of our remaining finalists will not come away empty-handed. They will each get also a $500 stipend fellowship. And that's a new feature this year. So altogether, we have $14,000 in cash prizes at stake tonight. And we have other new prizes this year. These semifinalists who didn't advance to this final round, they'll each receive $250. So that's great. Yeah. So in addition to helping provide increased prizes for our Grad Slam participants in the semifinals and final, we're building a solid foundation for Grad Slam program to grow even more so we can reach more students and provide even more professional development opportunities for every area of the campus. So I next want to introduce or recognize our Grad Slam sponsors, the UCLA Student Fee Advisory Committee, Startup UCLA, and the California Nanosystems Institute for donating the space tonight. So thank you to our sponsors. Okay. As well, the following Grad Slam sponsors, all of whom are alums of UCLA and have been a part of growing the Grad Slam program since we started the competition in 2014. Please join me in thanking Charlie Steinmetz, Jerome and Randy Greenberg, Anne-Marie and Alex Spataru, and Van Schultz and Susan Schultz. Thank you. Thank you. Through their leadership, we are able to achieve another new milestone for Grad Slam through our Spark crowdfunding campaign. The project raised over $22,000 over 30 days. More than 30 donors, alums, students, faculty, friends contributed to this project and helped elevate an important professional development program that impacts students across the campus. So I want to thank everyone at the final today and those of you who are joining via live stream who gave to the campaign for your support, whether you've been a judge, presented as a student, or simply a fan. Thank you. It means a lot to our grad community. And two more acknowledgments. Special thanks to Emily Towner and Nyasha Maforo, our student ambassadors for the campaign. Emily was one of last year's finalists, and Nyasha was last year's Grad Slam champion. So thanks for helping with coaching and being an ambassador. And I also want to thank the Grad Slam team, the people who really put this event together tonight and throughout the season. Jackie Suero, Samantha Tago, Aliana Clark, Pia Arvisu, and Pete Cloas. So thank you all for that. And the acknowledgement page that you picked up on the way in lists all the folks who've helped make this competition possible, so we really appreciate that. I now have the pleasure of introducing my co-host. He is graduate student J.P. Santos, who's going to go over the details of the competition. He is a doctoral student in electrical engineering and the 2015 UCLA Grad Slam champion. He's also currently the vice president of the Graduate Student Association. Come on up, JP.
Thank you, Vice Provost and Dean Garrell. Good evening, everyone. I love this event so much. I believe that good research coupled with good communication brings about the best contribution to humanity. The Grad Slam has personally helped me realize the effect of my research and how it broadly contributes to society. And back in 2015, when I was honored to be UCLA's Grad Slam's champion, it has tremendously helped me attain a prestigious fellowship. Therefore, I'm honored as this year's Graduate Student Association's external vice president to share this beautiful night with you to highlight the fabulous graduate research students in UCLA are involved in. We are very happy that family members and friends who cannot attend tonight are able to view the competition via live webcast. For those of you who use social media, please tweet, Instagram, and Snapchat away. Please use the hashtags #UCLA Grad Slam, #UCLA Grad Slam 2020, and #Grad Slam over here. There's a timer clock facing the stage. There will be a 10-second countdown to cue each speaker to start at the end of the 10 seconds. If the speaker goes beyond the three-minute limit, points will be deducted from the final score, beginning with a 1-point deduction at 3 minutes and 3 seconds, and a 1 point being taken off every 2 seconds. The speaker continues after that. So, presenters, if you reach 3 minutes, stop talking. Between each presentation, the judges, who are seated in the first row here, Vice President and Dean Garrell will introduce our judging panel shortly. We'll have about 3 minutes to complete their scorecards. During that time, I will be talking to each presenter so we can get to know each of them a little better. After the last presenter, we will take a quick 10-minute break while our tabulation committee totals the scores and determines the winners. During the break, each of you will also be able to vote for your favorite presenter. You can vote on the web through your smartphone or with a paper ballot. Even people watching online can vote. There's a camera in the back. During the break, you're also welcome to stretch your legs, take a bio break, and talk with our presenters. When we return, we will announce the winners, take some photos, and go back in the atrium for a celebratory reception with food and drinks. Now, I will turn you back to our Vice Provost and Dean Garrell, who will introduce our panel of judges and get the competition started. Thank you, everyone.
Thank you, JP. Okay, judges, you have a very fun and challenging job this evening because you're going to hear amazing presentations, fascinating research, many different fields, and you've heard the criteria. It's not about whether a student is going to cure a disease or land on Mars. It's about engagement and communication and effectively presenting their work. So judges, as I announce your name, please stand, turn, wave to the audience, and please remain standing until I've read all of your names. And audience, just hold your applause till we get to the end. First, I'll introduce Anne-Marie Spataru. She's a cabinet member in the UCLA Chancellor Society and alum, MBA class of 78. Jerome Greenberg, clinical professor of medicine in the David Geffen School of Medicine, and he's an alum from biology. Charlie Steinmetz, he's an alum from the Anderson School of Management. Kristen McKinney is the director of UCLA Student Affairs Information and Research Office and a UCLA alumni. Mary Osako, vice chancellor for strategic communications, an alum from psychology. And David Jackson, professor emeritus from the Department of Earth, Planetary, and Space Sciences. So thank you, judges. You may be seated. And now it is time for the competition to begin. You ready? You ready, guys? Okay. Our first presenter will be Wadi Chalgam from Mechanical Engineering.
Everyone, please take a deep breath in, close your eyes, and exhale. Imagine this was your last breath because of a silent killer. But who is the silent killer? It is carbon monoxide. And it is formed when natural gas does not burn up completely, creating a poison that we cannot smell or see. What a sneaky killer. Can you believe that 500 people die every year because of this poison? It actually kills more Americans than mass shootings and terrorism combined, and it is the fourth leading cause of death in the US. Most homes have carbon monoxide detectors, but the problem is their detection time. Even a few seconds can be too late sometimes. 1% concentration of carbon monoxide in the air makes you unconscious after 2 breaths and kills you in less than 3 minutes. So how can we better detect the silent killer before it enters your house? And that's where my research comes in. What I am about to share with you today will save a countless number of lives. I created a novel prognosis and real-time health monitoring framework for gas pipeline system integrity management. For the prognosis part, I developed failure predictive models that consider all possible causes of pipeline failure. They detect leaks before they happen by simulating the degrading condition of the aging pipe over time. These models will help us with strategic preventive actions, such as sensor placement optimization, which highlights the best places to place sensors, and maintenance schedule optimization, which proposes the best times to perform pipe inspections or repairs. You know, and I know that unexpected things happen all the time. So what if something goes amiss and the pipe leaks? And that's where the second part of my research comes in. When leaks are detected by the sensors in nanoseconds, the server I created sends an instant SMS to your family and calls 911 with a pre-recorded message. It also turns off the gas valve instantly to prevent any more gas from leaking, so that when your family arrives, they will find you alive, with a small headache though. In addition, I created a phone app to show you the real-time data of the safety level of your house, so that while you go shopping or run errands, you can be reassured that your dog or cat is safe. In few words, my research is like giving smart glasses to a colorblind person to show them color again, to show them the invisible carbon monoxide and save their life using science and technology developed here in UCLA. Thank you.
So, congrats, Wadi.
Thank you very much.
So, as we begin this Q&A, I was just wondering, just thinking of some questions here. Like, what's something that your professor does not know about you?
Oh, that's a good question. Actually, one of my big dreams is to become a famous stand-up comedian.
Oh, yeah. So how does that connect with your research?
Well, I always try to make my research related to our daily life, because engineering is something that we face in our daily routine, and what we do in our labs is trying to use physics-based models and science to solve these problems and enhance our daily lifestyle.
So because you want to be a stand-up comedian, you got to tell us a joke.
Oh, okay. Okay. Okay, there are 2 muffins baking in an oven.
There's no carbon monoxide,
No,
right?
no.
Okay.
The first muffin looks at the second one and says, "Oh, wow, a hot muffin." And the second one replies, "Oh, wow, a talking muffin."
Great, great. So tell us, like, wow, that's a good comic relief. Okay, so like, tell us a little bit how, like, your journey about choosing UCLA for graduate school.
Since I was a kid, it was my dream to come to UCLA because it's the #1 university in America. And as kids, we always dream big.
Right.
And as a kid, I wanted to dream big and between UCLA, and that's why I chose UCLA.
Not Berkeley, right?
No, UCLA.
Okay. So what do you enjoy about, like, your research, like, graduate school at UCLA? Like, what's been, like, your highlight for so far?
So my highlight so far is when we use predictive models, is a little bit like magic, because predictive models, they try to tell us how to detect, for instance, in my case, leaks or failure before they happen. Right. And our pleasure as engineers comes when we save lives of people who could have died in some like events. So that's how we look at things in our lab.
And then if you, like, besides being a stand-up comedian, if you decide to continue in engineering, what do you want to do after?
I would like to honestly open my own startup company to use engineering for social good.
Okay. Okay, and I'm guessing you want to stay in LA? Or
yes, who can beat California weather?
Yeah, no, and well, again, thank you, Wadi. And
thank you. All right.
Good luck.
I would like to say thank you for everyone who came in. And thank you.
Thank you so much. Our second competitor is David Chia from molecular biology, who's going to tell us outmaneuvering drug-resistant cancer, a game of chess.
I know that this is a bit of a personal question, but how many of us have had a friend or a family member who has had to battle cancer? Just the thought of a cancer diagnosis is enough to make my palms sweaty and my stomach drop a little. It's staggering to me to think that cancer is the 2nd leading cause of death in the United States, accounting for 1 in 5 total deaths every year. But while this is a grim fact, it's important for us to keep sight of the positive. In over a century of government-backed cancer research, the strides that we have taken have been transformational. From the first demonstration that radiation could be used to kill cancer cells in 1903, to the adoption of chemotherapies, followed by targeted therapies, to today's focus on immunotherapies, doctors now have a wide arsenal of tools with which to combat cancer. But despite these advances, the question remains, why does cancer still take up such a large portion of this pie? A major reason for this is relapse of cancer following treatment. To better understand this, it's important for us to examine a timeline of relapse. Starting here, at disease initiation, a cancer patient will be diagnosed and then treated to achieve a remission. However, some cells can survive during this phase and remain completely undetected until they start to grow back out. This is termed relapse. Oftentimes, these relapses are no longer sensitive to our therapies, and when this happens, a patient will succumb to their disease. So, is there a way that we can target these few cells here and prevent the emergence of a relapse? This is the exact question that my research seeks to answer. I use cancer cells taken directly from patient tumors, and I model the disease in a dish. I followed this exact graph by treating these cancer cells with chemotherapy and then measuring thousands of genes in these few surviving cells. Using this approach, I've identified candidate targets that may play important roles in allowing these cancer cells to survive initial treatment. And importantly, I have found that if you block some of these targets, the cancer cells no longer regrow out. Now, as a graduate student, I've only been able to focus on one type of cancer. But I envision that this type of approach can be applied to the problem of drug resistance across all types of cancers. It's a little like playing chess against cancer, with the goal of always staying one step ahead of your opponent. By leveraging the technologies that we have available to us to understand how cancer responds to upfront treatment and then targeting those responses, my hope is that we'll eventually be able to force cancer into checkmate. Thank you.
So, David, I'm just curious, just based on like your presentation, I'm guessing you're good at chess. Are you good at chess?
Admittedly, no.
So, David, tell me this, like what's one thing that you would say that you love about your research advisor or advisors?
One thing? Just one?
Just one thing.
Just one thing.
We don't want to
Okay.
like make their ego blow up. But.
I'll try to keep it limited.
Okay, good.
My advisor has really given me a lot of freedom to explore, science and really take science on, with my own ideas. And I really think that that kind of freedom has given me so much in terms of training because, you have to make all of these decisions and, you have to decide how are you going to attack a problem, what's the best way to approach it, and, that's really been a major feature of my graduate training.
That's great. That's great. Like, how did you go about finding your research advisor? Did you interview?
It's like speed dating, really. I mean, you go around, you talk to people, and you try to find a good match.
I've kind of heard countless times that your PhD is almost like a marriage. I mean, do you kind of consider that to be your relationship almost with like your advisor, like a you said it yourself, it's kind of like speed dating. So how's your relationship? Like, describe your relationship with your advisor? Seeing
as my advisor is here.
Okay.
And her husband is here. I'm going to say no, it's not like a marriage.
Sounds good. So in looking back, like in your graduate experience, like what do you think is your favorite part about UCLA?
I was here as an undergrad.
Oh, great.
I'm here as a part of the medical school too, and I'm doing some graduate training. And every step along the way has been a blessing to be able to stay here. My family lives in Southern California, and for me, being able to stay at UCLA, every component of it has been amazing.
And I'm guessing after you finish, you want to stay like in the Los Angeles area, right?
We'll see.
So what do you like to do for fun?
So I enjoy, whenever I have time outside of the lab, I enjoy rock climbing. So I'll try to hit the gym and do some rock climbing.
Now
which is kind of like chess, I guess.
Right. But now the real question is, how much time is that compared to research?
Oh man. You make time for it. You make time for it. It's a lot of time spent in the lab, but where you do have free time, it really makes that free time more valuable.
Yeah, no, sounds good. Well, congratulations and good luck.
Thank you so much. Thank you.
Our third competitor is Mongwei Ko from Oral Biology and Medicine, who's going to tell us about natural killer cells' triumph over cancer.
Cancer is among the leading cause of death worldwide. The number of new cases per year is expected to rise to 23.6 million by 2030. And approximately 38.4% of men and women will be diagnosed with cancer at some point of their lives. which means 1/3 of people in this room will be diagnosed with cancer and very likely die from it. So what do? How do we defeat cancer? The answer is immune system. Immune system is designed to keep us safe. There are 2 major killer cells in the immune system. One is natural killer cells, NK cells. Another is T cells. We can see the tumor microenvironment as this chaotic world we're currently living in. In our world, there are policemen. They set up checkpoints at the intersection, checking everyone's ID and investigate suspicious people. We also have troops who were recruited, trained, and get deployed to take out the enemy they recognized. In our body, immune system is responsible to keep order. Natural killer cells, NK cells, are like the policemen. They check the self-signal of the cells and kill those with no ID. On the other hand, T cells, they learn certain patterns and target those sick cells by recognizing the patterns on their cell surfaces. As we all know, cancer cells are mutated cells. They are not normal. They do not possess self-signal anymore, nor have any recognizable patterns on their cell surfaces. So, to T cells, they are ghosts, which are impossible to see and therefore impossible to target. However, it is NK cells' nature to screen them out and eradicate the seeds of cancer. Therefore, instead of using T cells as the rest of the field, my research focuses on superpowering healthy NK cells in the lab and use them for cancer treatments. First, I put cancer cells in mice and give some of them this superpowered NK cells. And guess what? The ones who received the superpowered NK cells were found cancer-free at the end of the study. Those who did not died from the disease. Now, the next step, I will start transfusing this superpowered policeman into cancer patients' body to help them restore their defense system and combat cancer. And hopefully, no one in this room or no one ever will die from cancer. Thank you.
Thanks, Mom. Just curious, so when you injected some of these like rats with like these superpower things, did they become like Hulk or like Captain America?
Yes, they are Superman. They have superpowered. We have developed a probiotic in the lab, so we culture them with the probiotic, which is really good. And they become so potent in killing and differentiate the stem cells. We're on our way to deliver it to patients right now. That's very exciting.
That's fantastic. So how did you go about choosing UCLA for your graduate school?
So the first time I came to UCLA was at 2010, and I just loved the idea of like one bus ride, you can just get to the beach. So I thought that it would be the great idea to do my PhD here, because we all know how stressful the grad life would be. Mm-hmm. But guess how many times I've taken that ride?
So how much have you taken? How many
I can count with my one hand, like from the campus to the beach is like almost impossible. You have to devote time.
So like, is there some things that you've done as a graduate student, like while doing research, to help de-stress or like?
Yes, go to the gym is very good. I also bake a lot.
Ooh.
And I don't eat them. I share. I can't share with people, and people like appreciate it, and they just delight their day, which is like a feedback, really great feedback for me. Like I actually accomplished something. I made someone's day today. You need those little accomplishments to get all the way to the end.
That's great. So the real question is, what's the most difficult thing you baked?
Ooh, the most difficult thing I haven't not yet successfully make macaroons.
Ooh.
But this weekend I'm gonna make beef Wellington and baklava.
Ooh.
So, yes. and I will share, I promise.
So is there a reason why you want to bake these particular like?
For baklava, because I still have some pastry in my freezer. And beef Wellington is just a really nice compliment. So.
Yeah, that's great. Like, so, what has like been your favorite part about your research at UCLA?
I think doing research at UCLA is very privileged because there's a ton of support. Grad division is so great. They have writing section and everything. GradSlam is so good. And also there's a lot of free food on campus.
And yeah. Well, good luck and congratulations.
Thank you.
Our fourth competitor is Anjay Feng from molecular biology. The title of this is 99% useless.
I am a liver transplant surgeon. It's always my greatest fulfillment when the patient restore their health and get back to the family. But sometimes transplants are rejected and there's nothing we can do. This is because we don't completely understand how our immune system is regulated by our genetic code called DNA. 40 years after the first discovery of DNA, scientists finally decoded the human genome. The code comes out to be 4 fairly simple letters, A, T, C, and G. To build a human, you need 3 billion of them. As the most complicated creature, it's not surprising to have such a huge genome. But what surprises us is that only 1% is informative. So what about the other 99%? If they're not informative, then why do we carry such a huge amount of useless DNA? If we stretch out the entire genome, it's over 6 feet long. This is the height of an adult brown bear. How could this possibly fit into a single tiny cell? Actually, our DNA is extremely condensed and packaged into a substance called chromatin. The DNA is not squeezed and packed randomly like a bowl of messy spaghetti. Instead, it is folded into a very organized structure, territory by territory. Because our DNA is folded so tightly, not every part can be read. And my research focuses on how the structure of DNA changes in the immune response. In Batman, when Gotham City is in danger, they turn on the bat signal, and it's showtime. Similarly, our immune cells must turn on the danger signal in the form of changing their chromatin structure from closed to open to initiate the defense system. Let's do a small exercise. Can you see what's in my hand? Can you see the bat signal in my hand? Yes. So whether the chromatin is open or closed affects the activity of our immune cells. This is what we call the chromatin regulatory system. Amazingly, I have found the DNA regions originally considered useless change their chromatin structure, which allows our cells to fight off the deadly invaders. By sequencing the whole genome, I identify over 60,000 of these useful DNA regions, which could be the therapeutic targets to reshape our immunity. In fact, the 99% of human DNA, which was thought to be useless, carries enormous possibilities. Piece by piece, I firmly believe one day we will complete the treasure map of human genome, which will guide us to perfectly understand our immune system, so we can guarantee no rejection. Thank you. Hi, JP. I forgot already.
So, tell us a little bit, what's your favorite place at UCLA?
I think home, just my home.
So why is that? There's so many awesome things at UCLA. Why is your home your favorite place?
Okay, before we jump into this question, let me ask you a question, JP.
Oh, okay.
So what's your ideas about grad school?
Oh, man.
Yeah, that's a difficult question,
It
right?
is.
Is your PI here?
No, he's not.
Okay, let me tell you my answer. My answer is graduate school equals to endless failed experiments and pizza. Yeah, so like bear my broken heart every day because of the failed experiments, I always need a place to chill. So my home is the place that I can heal myself and get ready for the next day's challenge.
I should try
Or
that.
the next day's failure again.
Yeah, I should try that. So tell us a little bit about your hobbies, like besides going home and eating pizza.
Oh, then that's going to the lab. Yeah.
Wait, is your PI here?
He's on live streaming.
Okay,
right
okay,
now.
okay,
So
okay.
I'm pretty like, okay, it's free. Yeah, I think my hobby, the first one will be baking as well. I love baking sweet. It's because it's a healing process. You know how stressful it is. You know how much frustration that you will get during the whole graduate school. I should say graduate school equal to endless frustration and endless fail experiment. Yeah, but I think that it's a healing process for me. And also, I would like my other interest is making fun of my younger brother. I think most of you guys must have this kind of interest. Yeah, because he is very timid. So it's always my greatest fun, like, yeah.
So I gotta ask, because of your Batman reference, what's your favorite Batman movie?
I think it's the penguin one.
The Penguin.
I love the penguin one. Yeah, because one of my instructor, he looks like a penguin.
Wait,
But
is
it's
that
not
a good
here.
thing or bad thing?
I think it's pretty cute. I think
Okay.
it's pretty cute.
Well, congratulations and good luck.
Thank you so much.
Our next competitor is Cassandra Meyer, who's going to tell us about taming the neurodegenerative monster in multiple sclerosis.
When I was in high school, one of my best friend's moms said that she started to feel like a monster was taking over her body, like she didn't have control over her own limbs. She said that on some days, the monster wouldn't let her move her arms and made it difficult for her to walk. My friend's mom was diagnosed with multiple sclerosis. Multiple sclerosis, also known as MS, is a mysterious disease that we're still learning a lot about. We don't know how it starts or why it progresses, but what we do know is that in MS, the body's own immune system starts to attack the protective covering that surrounds brain cells. This makes it hard for brain cells to communicate with one another and with the rest of the body. That's why my friend's mom said it felt like a monster was taking control. When brain cells can't communicate efficiently, it can lead to vision loss, difficulty with movement, or even dementia and personality changes. Eventually, this monster can cause neurodegeneration when brain cells die. Unfortunately, there aren't any treatments that can stop neurodegeneration from happening. Now, we often associate diseases that cause brain cell death, such as Alzheimer's or Parkinson's disease, with old age. But MS is actually something that happens in young people, in their early 20s or 30s. In fact, MS is the most common neurological disorder amongst young people. Imagine experiencing dementia in your early 20s. So in my research, I wanted to see if there was a way I could stop this neurodegenerative monster from taking over. I started by looking at a sex hormone called estriol. Estriol is an estrogen that's produced during pregnancy, and we know that women with MS who become pregnant actually get better and show a massive reduction in their symptoms. And this is because of estriol. So I wanted to see if estriol could be neuroprotective and protect against brain cell death. But first, I needed to find out where cells were dying in the brain and what was causing them to die. And what I noticed when I looked at MRI images was that neurodegeneration was happening primarily in areas of the brain that were responsible for walking. And this was strongly associated with nerve damage in the spinal cord. This is important because we know that walking disability is one of the most common symptoms in MS. And we also know that the walking areas of the brain are directly connected to the spinal cord. So this suggests that nerve damage in the spinal cord is part of what's contributing to neurodegeneration in the brain. I wanted to see if I could prevent nerve damage from happening by treating with estriol. And that's exactly what I found. Estriol treatment in the MS model almost completely prevented nerve damage in the spinal cord and also led to neuroprotection in the walking areas of the brain. This discovery is a really important piece of the puzzle. Now that we know estriol can protect against brain cell death, we can start to learn how it works and use that information to tame the neurodegenerative monster and give MS patients back their control. Thank you.
So Cassandra, so what are your hobbies?
Yeah, so the little bit of time that I'm not spending in lab, I actually like to do leather work. So it's kind of a different hobby, but I like to tool designs into leather and
make different things. So you can make like wallets or purses or anything really.
That's great.
Yeah, it's kind of fun.
How did you get into that?
So that's actually a really good question. So my grandpa used to be used to do leather work, and he would always make us things, and so I was very inspired by all of his beautiful creations. So yeah, I also wanted to, and he gave me his tools. So
That's
kind of fun.
That's
Yeah.
fantastic. What are other
Yeah.
stuff that you do for fun?
Yeah. So I love to take advantage of the beautiful scenery that we have in LA, and I like to go hiking. In fact, recently I hiked Kilimanjaro, which was super amazing.
What?
It was really fun.
Wow.
It was a really good experience.
Wait, did
Everyone
you
should do it.
Wait, did you have to train for that, or did you just kind of go, well, I'm just gonna hike it one day?
Yeah, no, I did train,
Okay,
luckily.
good.
So yeah, hiked a lot of the mountains around here, and it was a great experience. Yeah.
Wait, so how long did it take you to hike Mount Kilimanjaro?
Yeah, so they have a couple of different routes. The route that I took, I think it was 6 days up and 2 days down, something like that. So
Wow.
yeah, well, we went the longer route because it's it's actually better to go the longer route because you can acclimate to the elevation changes. So
What was your favorite part about that experience?
it was actually kind of a spiritual experience just because it's just kind of you walking every day and you're just kind of learning to take one step at a time, and you're not focusing on the end, you're really focusing on the journey up there. So
Now, the real question is, did your advisor know about this trip?
I did tell my advisor. I did let him know, and he allowed me to leave the lab for a little bit.
So what else is like your favorite part of UCLA, like, or the graduate experience so far?
That's a good question. Yeah, I think probably my favorite experience about being a graduate student has actually been working with undergrads.
Okay.
I love working with my undergrads. They're so smart and they're so inspiring, and it's just fun to be around people who are excited and interested in science.
What do you think is the most difficult interaction that you ever had with an undergrad?
That's a really good question. Oh man, I don't know. They're all so great. They're really nice. I don't know.
Well, good luck and congratulations.
Thank you.
Wow. So our next competitor is Lucia Iquino, who's going to tell us about unlocking the DNA.
Have you ever heard somebody say that you are what is written in your DNA? This sentence is quite scary, right? Do I have a say in the type of person I become, or is it all just written in my DNA? The DNA is the molecule that contains all the information that is needed to build a human body. It's like those Lego instruction manuals that you use when you were a child to build beautiful houses. Our cells use the instructions written in the DNA to build the human body. In fact, each one of my cells is its own personal copy of my DNA. But wait a minute, if the cells of my skin have the same DNA as the cells of my eyes, of my hair, even of my blood, how comes they build tissues that are so different? How did they know what they were supposed to make? Well, the DNA is a very big library of books, and each book has a colored cover, which we call epigenetic mark. The cells of my hair and the cells of my blood have the same DNA, so the same set of books, but the covers can be different. And the cover is what tells the cell if a certain book should be read or not. The green cover, for example, means you need to read this book. And the red cover means don't read this, you don't need it. And those red covers are really important because if a certain tissue starts using too many green covers by mistake, it will start growing some hair, a tooth, muscle, blood, all together like that. And I'm not joking here, that one on the right is a real tumor mass from a real patient. So yes, you better make sure you got the right covers. When I started my PhD, I found all of this very fascinating. But there was one question that was bugging me. How does the cell know what the colors of the covers mean? I really wanted to understand this, but certainly I couldn't do it with humans. Would anybody ever let me change the covers of their DNA with the risk of having their beautiful hair transform into blood? Probably not. So I decided to work with plants, which indeed have a very similar system of books and covers as humans do. And I figured that there must be something that specifically recognizes those red covers, as if there was a red lock that can close the red books only. So I started looking for this lock in my plants. And after several attempts, I found it. And this is the experiment that proves it. I took 2 plants, and in the one on the right, I eliminated this lock that I had found. And then I analyzed the DNA. And I saw that the plant on the right was now reading those red books, which were supposed to stay closed. So this shows that the lock that I discovered is required to keep the red books closed. And who knows, maybe one day we'll be able to use this lock to close those books of our DNA that we don't like. If you have a genetic disease, your illness is encoded in one of those books. So what if you could just keep it closed? That disease would never manifest itself. Thank you.
So does that mean, like, based on your research that, if I somehow figured this out, that, I'll be like that Superman, like, graduate student who will never, like, have to sleep ever again?
Yeah, of course, you can use my lock and close whatever books are the ones that make you need, actually, the sleeping, and yeah, it's going to work.
That's great. That's great. I'm
Maybe
sure
not yet, but.
Well, I'm sure our advisors would love that, right? We could get more work done. No, I'm just joking. But
Yeah.
like, so what's like your favorite place to go out to eat here at UCLA?
Oh, here. Well, yeah, I don't really eat a lot on campus. I'm Italian, so I like to cook, and I usually bring food from home.
Okay.
But yeah, and so, but I know some good Italian restaurants around, so.
Okay, well, which one would you recommend?
Oh, well, my favorite one is Pasta Sisters in Culver City.
Okay.
Yeah. But yeah, there are a lot of good ones, but usually they're very expensive, so not really for students. But maybe after I get the $500 award.
That's great. That's great. So, like, what is like the most difficult Italian dish you've ever like tried to cook?
The most difficult. I mean, I think pizza is something that like it's quite difficult. I mean, like almost everybody can make it, but to make it kind of like good, it takes a while. And the weird thing is that now that I'm doing it here in the US, it tastes better than when I was doing it in Italy. I don't know why.
Really? Wait, why is that?
I mean, a lot of things are different. The flour, the water, like all the ingredients are so different. And like most of the cakes that I bake, they are a lot better when I make them in Italy. But pizza, for some reason, is better here.
Wow. So I mean, is there like a secret ingredient that you put in your pizza that like distinguishes it from like your
No,
rest?
so I think that the most simple things are the best. So I like to put like very few ingredients. So just like simple tomato sauce with good olive oil and oregano.
So how did you end up choosing UCLA?
Well, so yeah, I applied to many schools, and I was fortunate enough to be invited for interviews here. And yeah, I like the vibe here was just really good.
Yeah.
And of course, the weather was amazing, the city was beautiful, the ocean and everything. And then all the people were so nice and friendly, and I got this feeling of excitement about research and about everything, which is, in the end, what helped me decide.
Well, that's fantastic. Well, congratulations and
Thank
good luck.
you. Thanks.
Thank you. Our next competitor is Gil Torton from Neuroscience, preventing blindness on a cellular level.
I want you to take a moment and imagine that you're blind. How would you have gotten here today? Could you have eaten breakfast on your own? Could you even found this room? Vision is the primary way that we interact with the world, yet every year hundreds of thousands of people are stricken with diseases like macular degeneration and retinitis pigmentosa, leaving them completely blind, drastically lowering their quality of life. Now, vision is a fickle process. There are a lot of little things that have to go right for you to actually be able to perceive the world around you. And the main place where things tend to go wrong in disease is at the interaction between your photoreceptors, so your rods and cones, and a cell type called the RPE. At the back of your eye, in your retina, you have a layer of these rods and cones, and these are the cells responsible for taking in light information and sending it to your brain. So when you lose these cells, you lose your vision. Directly behind those, you have a layer of these RPE cells, and the job of the RPE is to keep your photoreceptors happy and healthy. And they actually do that by physically ingesting pieces of your rods and cones, breaking down their contents, and recycling them for future use. So we've actually known about this process since the 80s, but even still, we don't have a clear picture of even how it works, let alone why it might go awry in disease. So my research really aims at utilizing new technology to better understand this process. So what we can actually do is take 3D movies of this ingestion taking place. So in this movie I'm about to show you, the green is the RPE cell, and the red is a piece of rod photoreceptor. And as you can see, the RPE makes this physical cup and engulfs the piece of rod, pulling it in for degradation and recycling. So I have some preliminary data that shows that by modifying outside factors, things like temperature or things like the density of these RPE cells, we can totally change the efficiency of this process and even change the physical way that this cup forms. I've also been utilizing a number of drug treatments that others have been using in similar systems as a way of really picking apart and modifying the different proteins involved with this process to really try and get a better understanding of how this ingestion works. And I want you guys all to remember that this process, it's perfectly normal. It happens in everyday life, but for some reason, when this process breaks down, your rods and cones start to die and you lose your vision. And that's what's actually happening in a lot of these major diseases that cause blindness. I really hope that by taking these 3D movies and by modifying these outside factors and using these drug treatments, I can really get a clear picture of exactly how this process takes place. And more importantly, try and figure out clues as to how and why this process might go awry in disease. I really hope that by doing this, I can find new insights into vision science and find ways to prevent blindness in the future. Welcome back.
To UCLA.
Yeah, I think my journey with science in general kind of started in my first year of undergrad. I joined a lab kind of on a whim. I just saw an ad for it and I was like, oh, that sounds fun. And I went in and I was doing a lot of like electron microscope work. And if you guys don't know what that is, it's pretty much, that's like the highest resolution images we can get at a cellular level. And seeing, the ability to see these cells, see these organelles at such a clear resolution, it was just unbelievable to me. And I just got pulled into science from there. And I kind of kept going. And once I got to the end, I was realizing, I want to do grad school, I want to do a PhD, I want to study this even further.
Wow. And is there like a reason why UCLA was the one grad school that you got to go to?
I don't want to say the food, but it was definitely a big thing. I think the really big thing for me was I'm a really big fan of mentorship. I really like teaching younger students and trying to encourage them on their way. And UCLA has a lot of really good programs and a good infrastructure for that. There's a lot of incredible students here, and as much information, knowledge as I can pass on to future scientists, I would love to be able to do that.
So tell me this, like what's one thing that you do outside the lab that you do to like de-stress and just have fun?
Yeah, so there's a couple major things. So the one big thing is I'm an artist. I do clay sculpture and resin work. I've been doing some kind of clay work for at least 12 years now. I'm really big into that. And then the other one, a bunch of the other finalists already touched on it, but eating. That's kind of a yeah.
So how did you get into like the clay sculptures and all that? Like, is that like just a personal hobby, or did you just find that like one day, or like did just someone influence you?
Yeah, when I was in maybe 5th or 6th grade, there was an art fair at my school, and so a bunch of artists came, and there were painters and sculptors and ceramicists and all this different kind of stuff, and you kind of try different things. And I sat on the pottery wheel at 9 a.m. and I was still there at 5 p.m. when they closed, and
Wow.
I was doing pottery ever since.
Yeah, no, I've heard that pottery is really fun actually, just to like get your hands.
Yeah.
I guess it's good for me as an engineer because I like to get my hands on things. But
Definitely.
so, like you kind of mentioned food. So what's one thing you would recommend to our fellow graduate students here as a restaurant that you personally like around here in Westwood, or like just on campus?
Campus. It's gonna sound weird, but in my opinion, the best restaurant on campus is the Ronald Reagan Medical Center. The hospital has weirdly good food, so yeah.
That's great. Well, congratulations, Gil.
Yeah,
and
thanks
good
so
luck.
much. Thank you.
Thank you. Our next presenter is Kanav Saraf, who from bioengineering, helping your doctor catch silent heart disease. Take it away.
Brace yourselves for an inconvenient truth. you might have a deadly heart disease right now that's not showing any symptoms. Your doctor couldn't catch it at your last medical appointment, and it might only be getting worse by the day. But don't worry, what I'm about to share with you today will provide great hope for the future. The disease in question is aortic stenosis, in which the opening of the heart becomes narrow, like a clogged ketchup bottle. This prevents the flow of blood. Over time, the heart has to work harder, but it can only do so up to a limit before finally giving up. The unfortunate reality is that patients with this disease do not show any symptoms for several years until the disease becomes so severe that surgery is the only option for treatment. Studies have shown that catching this disease early can significantly impact the lives of patients, sometimes even without surgery. So, is it possible to catch this disease early? Well, that's a question my research team and I asked ourselves a few years ago. The result? We created a device that can catch silent aortic stenosis with confidence. Turns out that this disease isn't that silent after all. I created a software for this device that detects variations in heart sound that cannot be heard by the human ear. Sounds very simple and easy, you might think. What's so unique about this? Well, you see, old softwares that tried to do this in the past worked well in the research lab, but failed to work when they were brought out into the crazy environment of a hospital. Here you have patients talking to doctors and nurses, alarms, announcements, a lot of commotion. Patients may even show more than one heart disease that impacts the way their heart sounds. What we did right was to account for all of these challenges from the get-go, instead of them becoming an afterthought. In fact, I tested this device on 100 patients at the UCLA Medical Center. Patient walked in, the doctor put a sensor on their chest to record their heart sound, and then the reading on the software gave them a confident diagnosis, all in the matter of minutes. This software was able to successfully identify 92% of people with this disease, which is a significant improvement on what is currently 0%. The best part, no dangerous delays. This can be our new reality, a quick, inexpensive, and readily available tool that can help your doctor catch silent aortic stenosis. Imagine walking out of your doctor's appointment knowing with confidence that you don't have this disease. Imagine the hundreds and thousands of lives that could be impacted by a tool like this. Imagine having the world's best specialist as your doctor's assistant. Well, that is the future, and we're one step closer. Thank you.
So Kanav, thank you. So you're talking about like in your research about like catching, heart disease early, this silent thing. So what's next for you? Like what's, it seems like we're one step closer to saving humanity now. So that's the next thing for you?
Well, that's a good question. I'm really looking forward to debuting the second version of this device that is going to be able to detect the next biggest disease. And I'm going to be doing that at our cardiology gathering later this month. So I'm really looking forward to that. That's going to be like the first time I'm going to be on a platform like that.
Can you give us a secret scoop on what that version 2 will look like?
I wish, but maybe I'll get in touch with you a few weeks from now.
So I'm guessing with something like just based on what you talked about, music seemed to have some inspiration to you. Can you tell us about that? Has music played an involvement in your life?
I wonder how you know that. But yes, sound and rhythm, they are present in our lives continuously. For me, music sort of started at a very young age, like 7 or 8 years old. I played this one Indian classical instrument called a tabla, which is like 2 small drums that you play with your fingers. And I continued playing that. I just picked up playing the drums a couple of years ago, so I'm doing that. I think it's a great way for me to make sure that I have a good rhythm in my life that's balancing out my research and a good discipline. And it really helps me exercise both parts of my brain.
That's fantastic. Yeah. Is there a certain genre of music that you listen to that you'd like to play along with?
I like to present myself as someone who's into everything, every genre of music. I wouldn't want to paint myself in a corner because there's so much you can learn from each genre, so many techniques that are specific to them that you might not learn if you were to just pick one.
So I've also heard an interesting tidbit about you is that you know 3 languages. Is this true?
Yes, that's true.
So now, If that's the case, can you give us like a sentence in English and translate it 3 different times, or well, 2 different times?
So in Hindi, it would be मैंने आज सुबह चाय नहीं पी. In German, it would be ich habe heute Morgen keinen Kaffee getrunken. And in English, that means that I did not drink any coffee this morning. And the reason is that I had this natural energy in me because of the event today. So that kept me going.
Well, congratulations and good luck.
Thank you very much.
Awesome. We're up to our second to the last competitor, and that is Caitlin Emmett, who's going to tell us about how songbirds can help us find new treatments for autism. Take it.
Imagine what it would be like if we had the power to give a nonverbal autistic child back his voice. Today, I'm going to talk about how research in songbirds could finally make this possible. The birds shown here are zebra finches, the most widely used animal model for speech and language. Like human children, young songbirds learn to communicate by first listening to and then imitating their parents' vocalizations. Birdsong and human language are made possible by connections between the same regions of the brain, and the genes that underlie birdsong are also important for human language. Given these similarities, I wanted to know what songbirds could teach us about neurodevelopmental disorders that affect communication, starting with autism. Autism prevalence is on the rise, affecting 1 in 59 kids. There are currently no drugs available to treat communication deficits in autism patients. A key feature shared between songbird and human development is that we both learn during a critical period, which is a window of time when it's easy to learn a new language if you're a human, or a new song if you're a bird. My data suggests that in some patients with autism, the critical period window closes too soon, before the child has a chance to learn to speak. I hypothesized that a novel pharmacological therapy would reopen the critical period and improve song in birds with impairments. I'm going to play you first the song of a bird with communication deficits. As it plays, listen for a lack of organization or patterned repetition. Well, usually there's audio, but just from looking at this spectrogram, which is a visual representation of the bird's song, you can see that there's no pattern or repeating elements here. However, I was amazed to discover that after just 4 weeks of treatment, this same bird was able to organize his song and perform it reliably as if he had never been impaired at all. This is the same bird I just showed you, but after receiving a treatment for his communication deficits. As you can see, his ability to organize his song is dramatically improved. Thanks to advances in genetics, we're now entering a new golden era for drug discovery. The time is now to take on the development of therapeutics for disorders that were once thought to be hopeless. Through my research, I've identified a novel therapeutic that normalizes a process that goes awry in severely affected autism patients, and could potentially one day restore the opportunity for them to learn to speak. That's the future this work is making possible. Thank you.
Caitlin, thank you. So Caitlin, does music play a role in your life? I mean, it seems like
I love music. I love going dancing with my friends.
Okay.
You know, so many great memories around seeing. Yeah. The birds. They've actually inspired me to consider how they could be incorporated in making music. So maybe before I graduate, I'll finish that project.
So what was the inspiration behind the songbirds? Is that something that your advisor and yourself just
So I've always been really interested in the evolution of language. And I started researching it and getting into the literature. And I came across this idea that birdsong and human speech are both made possible by changes in the timing of development. So we're born much less developed than other apes, and birds that have learned vocal communication are born much more altricial or premature versus a chicken, which can crack its shell and hop out and run around, almost instantly. So this led me to believe that changes in the timing of development are what underlie this shared ability in both species.
Wow, that's fantastic. So you mentioned you like to dance. Like, is there a particular genre of dancing that you enjoy personally?
Well, I don't think I even told him this, but I started taking hip hop dance recently. So I don't have any moves that I can break out here. But it is a good way to de-stress and kind of, have balance, as previous presenters have alluded to.
That's fantastic. So what about, like, what's been your favorite, like, UCLA graduate school experience so far?
It's hard to pick just one. I think a great feature of UCLA is that the faculty are really accessible, so that's a huge bonus that these really established PIs are willing to spend their time talking about science with us and sharing their knowledge with us. But if I had to pick one location at UCLA that's my favorite, I would have to say that's the Meteorite Gallery.
Oh, okay.
Truly a hidden gem.
Yeah, I don't think I've even heard of that one, actually.
Oh, you should check it out.
Where is it?
It's in the geology building.
Oh, what?
Yeah.
I'm stuck at engineering 4 all the time, so it doesn't help. Okay, and then, like, is there something that, like, that made you choose UCLA over, like, other graduate schools?
I would have to say it's my amazing PI, Stephanie White. I was reading the literature, and I came across her paper, which uses a really interesting bioinformatics technique called weighted gene co-expression network analysis to analyze gene expression in birds that have been singing compared to birds that were not singing. And I thought, wow, this is so profound, we could use this to discover new therapeutic targets for disorders that affect communication. And here we are.
Awesome. Well, congratulations
Thank
and
you.
good luck.
All right, now we are going to welcome our final finalists, and then we're going to put you to work, so be ready. Our last speaker is Karthik Sarma, who's from medicine, who's going to tell us about federated learning for medical imaging.
There's nothing more important to the physician-patient relationship than trust. An important part of that trust is our patient's faith that we will never reveal the extremely sensitive information that they tell us during the course of their care to anybody else. It's that faith that makes nurses and doctors the most trusted professionals in America. And to enable that faith, my med school classmates and I, almost a decade ago, all swore the UCLA Healer's Oath and promised that we would never reveal our patient's private information. Of course, a lot has happened in the world in the last 10 years. These days, it seems that in almost every single part of our lives, we are expected to surrender our privacy, to use the tools we use every day, from social media to banking to even our home appliances. Sometimes it seems like healthcare is the last bastion of privacy we have left. And what has caused this Armageddon in privacy? Well, a big part of it is the advent of machine learning. What's machine learning? It's a methodology by which you can take data you've collected from many, many people and use it to train a valuable predictive model. For example, imagine taking 100,000 MRIs from patients all around the country and using them to train a predictive model that could tell you if you had cancer or not. The value of such a model would be incredible. If we had a computer that could tell us if we had cancer, we could deliver much better medical care at much lower cost with far fewer errors. But if the price of that algorithm is that we have to give up the last bastion of our privacy, is it really worth it? Or is there a better way? And of course, here at UCLA, we're working on a better way, and it's called federated learning. Here's how it works. Instead of taking our patient's private data and sending it to somebody else so they can build a machine learning model, we train local machine learning models at every site where our patients are seen for care. We use whatever data is available locally, and once we're done training it, we sprinkle it with a little bit of privacy-preserving noise to de-identify it from any patient information. We then send all of those local models to a global federated server where we aggregate them into a global model that takes the best part of each local model and combines it together. We then take that global model and send it back to every site where we continue to train on new data that they collect from their patients. And we iterate this entire cycle over and over again until we have the best possible global model. And importantly, along the way, we have never revealed our patient's private information to anybody else. Here at UCLA, we're trying to validate this approach by forming our own little mini federation comprised of ourselves, the NCI, and SUNY. And together, we're trying to build a federated model to predict whether or not there's cancer or not in a prostate MRI. The idea here is simple. If we can validate the approach on this use case, we should be able to scale it up both by adding more sites to our federation, but also by adding more tasks, like the analysis of CT images or X-rays, with the overall goal being we want to show that we can build the state-of-the-art models that our patients need without sacrificing their privacy in the process. Thank you.
Congratulations. And
Thanks, JP.
so tell me this. So what inspired you to go into in medicine? Like what was that? Like what was like the story behind that?
It's a good question. When I was an undergrad, I was actually a CS major at Caltech, and medicine was as far as possible from my mind as I could think. But I actually signed up for a program at Caltech called the Health Advocate Program, where it's an opportunity to be a first responder for your dorm. And kind of through that program, I realized I actually really enjoyed medicine, the practice of medicine, and so I decided, hey, maybe I can combine the two together and do something cool. And that's what I'm doing.
Yeah, because I found that interesting, like combining medicine and like computer science, and I was like, wow, like you must have had some sort of like software knowledge before that. Right?
For sure, yeah. So I mean, I was trained as a computer scientist, but I think that, look, the future of healthcare has computers in it. Now, when I started med school about a decade ago, I told people what I wanted to do, and they thought I was crazy. Computers are never going to be involved in medicine. A robot can never replace my doctor. Now I talk to med students, and they tell me, oh my God, is medicine over? Are robots going to replace us? And it's obviously not true, but it's been fascinating to see what's happened in the last 10 years.
Wow, that's great. So like, what's like your thing that you do personally to like help de-stress and have fun here at UCLA?
Well, I don't know if this is going to answer the de-stress. What I'm really passionate about is advocacy. Oh. So a lot of the stuff that I do that isn't related to my research is healthcare advocacy. So I'm really interested in health system reform, and kind of I work in the federal government to try and implement new reforms that'll make the American healthcare system better. So it's not necessarily de-stressful, but it feels good and it's something different.
Yeah, no, I'm guessing. Like, does that like occupy you for the most part, like outside of the research?
Oh, well, no, I'm a grad student first. I think we all are. Everyone in this room knows how little time you have as a grad student to do other stuff. Right. But yeah, I think we all, as a bunch of people said, we make the time to do things that we care about because it's important in life.
Okay. So how about this? Like, what's like the thing that you would say is been the most fun experience you've had at UCLA?
Oh boy, the most fun experience I've had at UCLA. There are a lot of things that come to mind, but I think the moment when it's called the white coat ceremony, when we first started med school, where all of us get together and we swear the healer's oath together. I mean, it's hard to explain, but it really is a super meaningful moment. We're all together at Royce Hall and we're all talking about what we hope to do. It's something that sticks in your mind.
Yeah, no, I bet. I mean, like just the imagery of that seems so like, it's like, seems so like real and just serious and like honorable,
It's the start of something that hopefully will be great and meaningful.
Yeah, well, congratulations.
Thanks very much, JP. Thanks. Thank you.
Let's give all of our students a round of applause and congratulate them. So you all know a whole lot more than you knew before you walked into the room, right? And that's because these students have told you discoveries that aren't in the books, they aren't in the papers, they aren't on the radio, they aren't in the news, they aren't in social media. You heard it all first. Some of them have some publications out, I know. But they also told it in a way that you could see it and hear it and experience it for yourself, because you're probably not out reading PLOS ONE or Cell Biology or those journals every day. And I think even more importantly than learning about the what, it's getting to meet our amazing UCLA graduate student researchers, seeing how passionate they are about their work, how intelligent, obviously, but how curious and just how creative, that imagination, and just that fire. You can see that drive and how they're going to carry this forward and change the world. So bravo to all of them. All right. And please join me in a special appreciation to my co-host, JP. You're fantastic. Thank you. All right, so now I've got to put y'all to work. Audience 2 up on the web there. Okay, it's the audience choice voting. So I ask you to turn your attention to the screen. Please use the hand ballot. As soon as you're done, take that ballot to one of the blue boxes on the gold tables. That's easy to remember. Blue box, gold table outside there. Once you've placed your vote by phone or by the card, chat, take a break, bio break, walk around. We're going to have a full reception after the award. So it'll take about 10 minutes for us to get the scoring done. So just enjoy a few minutes to stretch, have an exercise break, chat. We will call you back in, do the really fun stuff, which is give away prizes and money and applaud our folks some more, and then we'll have a little party. So enjoy. See you soon.
There's been a change to the number you text to for your vote.
For texting, if you're texting your vote, please text UCLA Grad Slam 333 to join.
It's positive, like you're right.
Okay, the moment we've been waiting for. Very exciting. Welcome back, everyone. All right, so we're going to start by acknowledging and celebrating all of our grad student contestants tonight by presenting each of them with a Grad Slam 2020 finalist certificate. Ooh, yes. Assistant Vice Provost Sam Brasola, please come to the podium. He's going to announce the names. JP is going to join me up on the stage to present the certificates. And competitors, when Sam calls your name, please join JP and me up on the stage to get your certificate. We'll get a photo and then return to your seat. And then we'll go into the big news.
Our first finalist from Mechanical Engineering, Wadi Chalgam. From Molecular Biology, David Shia. From Oral Biology and Medicine, Meng Wei Ko. From Molecular Biology, Anjay Feng. From Neuroscience, Cassandra Meyer. From Molecular Biology, Lucia Iquino. From Neuroscience, Gil Torton. From Bioengineering, Kanaf Saraf. From neuroscience, Caitlin Ammett. And from medicine, Karthik Sarma. Congratulations to all our finalists. I have the pleasure of announcing the audience choice winner tonight is Wadi Chalgam. In third place with a $2,000 fellowship is Kanaf Saraf. In second place with a $3,000 fellowship is Cassandra Meyer. And the 2020 Grad Slam champion, who will be winning $5,000 tonight and representing us in May in San Francisco for the Grad Slammy, is Anjay Feng. Final round of applause to all of our contestants and to all of our finalists tonight.
And they also, by the way, get these really cute trophies. Yeah. That concludes our formal program. Awardees, please stick around. We're going to capture some more pictures of you, so don't escape. Judges, we need photos of you too, so you can't escape just yet. But then there's great food and drinks outside. Everyone else, please make your way to the atrium. Thank you so much for making this event awesome. Audience participation is everything. Thank you.